Good afternoon. My name is Frank Anscombe. I'm Professor of Statistics at Yale University. I was formerly a member of the Committee for Videotaping Distinguished Statisticians of the American Statistical Association. This afternoon, we have a discussion or conversation between two very famous figures of the statistical world, John Tukey and Frederick Mosteller. John Tukey is Senior Research Statistician and Donner Professor of Science Emeritus and Professor of Statistics Emeritus at Princeton University. He was also, until his recent retirement, Associate Executive Director, Research at the AT&T Bell Telephone Laboratories. Frederick Mosteller is Chairman of the Harvard Department of Health Policy and Management. He is Roger I. Lee Professor of Mathematical Statistics in the Harvard School of Public Health, Professor of Mathematical Statistics in the Harvard Department of Statistics and in the Harvard Department of Psychology. He's a member of the faculty of the John F. Kennedy School of Government and of the Medical School of Harvard University. John Tukey and Frederick Mosteller have known each other for a long time, since, I believe, 1939. They have collaborated in a number of major research projects and also over the years have had numerous informal contacts and discussions. We are now going to hear from them reminiscences and reflections on developments in statistics during their long association. We will hear of their early days at Princeton, of their collaborative studies, and of their attitudes to statistics and to the current state of statistical science. Let's begin with the early days at Princeton. John, you were there a little before Fred. Would you care to begin?
Thank you. Well, I came to Princeton as a chemist in 1937. Took prelims in math at the end of that year and a PhD in topology a year later. I didn't know as much about the state of statistics in the mathematics department then as I learned later. It was a difficult time. If it hadn't been for Luther Fehler Eisenhardt, I don't think there would have been any statistics in Princeton, and I'm sure that Sam Wilkes would have done his important work somewhere else. In May '41, I went over to war work, and for most of the war, except when they were away, I spent a lot of time with Charlie and Agnes Windsor, Charlie both day and night, and so on. I learned a lot from real data, but I think I learned even more from Windsor. And so I came out of the war a statistician, not a topologist, a change I've never regretted.
I was sent to Princeton as a graduate student by my own mentor, Edwin G. Olds. And I was astonished when I got to Princeton and met Wilkes because he looked so much younger than I did. Of course, you'll see me now, but then I looked fairly young and he looked younger yet. And I could hardly believe that he was going to be my teacher. Also, he was a very different man from Edwin Olds. When Edwin Olds wanted you to do something, you didn't have any misunderstanding about that, John. He just told you. When
Sure.
Wilkes wanted you to do something, it was hard to catch it. You had to be alert for it. he would hint around that it would be nice if somebody did something of a certain kind, and you had to really make it out that he meant you. Coming from Olds, it was a little hard for me to make it out sometimes. Wilkes was very busy. He was in educational testing service work, in sample survey work, working for the Navy, working for the National Research Council, and a member of the Social Science Research Council. Very busy man. And although tea was a sacrosanct institution at Fine Hall when I was there, Wilkes almost never appeared, except to make an appointment with somebody or to settle something that really, some kind of business. He almost never picked up a coffee cup and almost never ate a cookie. There were a few students there at that time. Alexander Mood, George Brown, they were both ahead of me. Wilfred Dixon was in my class. Phil McCarthy, who's now at Cornell, is in my class, and a young man named Villavasso. The total statistics curriculum consisted of one course, which Sam taught throughout the year. And we met lots of statisticians because after Wilkes built his home, people were always passing through Princeton, and all the graduate students met Neyman and Hotelling and A.T. Craig, Cecil Craig, Wald, Koopmans, Deming, Schuhart, Dodge, Romig, and so on.
Right, well, I don't have too much to add to this. Before I got involved in other things and started to become statistical, I'll have to say that not only was Wilkes not often at tea, but I very rarely saw him in any other way. He was hard at work, but not visible on the surface.
Well, the war brought lots of statisticians to Princeton. Cochrane came, and as you've already mentioned, Windsor, Paul Dwyer, and R.L. Anderson. Tukey, you were working at Fire Control Research, and my wife Virginia worked there as secretary to Merrill Flood. With the number of statisticians there in Princeton at that time, a seminar began, and it was an extremely active one. My recollection, John, is that we had many, many famous speakers, but that whenever we ran out of speakers, you always had something to say.
Well, I can't confirm or deny that out here. And maybe I should clarify the term fire control research, which fortunately many people in Princeton thought we controlled fires. But really what we were working on in the beginning was stereoscopic height and range finders with an experimental setup down at Fortress Monroe. And then we moved on into a variety of less obviously related topics, including things like armored vehicle fire control, ballistic behavior of rocket powder, and then eventually we finished off the war as the coordinating group for a thing called AC 92, which was trying to find out how to make the B-29 more useful. But I think the important thing for this present thing was there were a number of statisticians there, and particularly toward the end of the war, after Brown and Mood had set up in a large house that's now occupied by my lawyer, that Sunday afternoons the statisticians would gather over there, and some people would do the New York Times crossword, some people would do this and that. I met George Snedeker in the garden of that place, for example, and other people of interest. There
was a fair bit of teaching of quality control at this time. working, and E.G. Olds and Paul Clifford came and helped develop a quality control program that was going throughout the nation. And Sam, of course, set such an enterprise up at Princeton. I participated in that, and I think later that was one of the reasons I was involved in Continental Classroom, that previous experience. Sam edited the Annals of Mathematical Statistics, and I was his co-editor. Was to say I was his assistant editor. And it was an amazing thing the way he got the annals out. On a Sunday evening when we were finished pouring some visiting firemen onto the train from Princeton, usually to New York or to Washington, he'd turn and say, I wonder if we shouldn't spend just a little time getting out the annals tonight. And that was the beginning of a long, hard night always, because Sam enjoyed the all-night effort. And about 5 or 6 in the morning, we'd pull out of there and go down to the post office and mail off another issue of the Annals. He also got me a job working with Hadley Cantrell. And Hadley was a social psychologist, very interested in using survey research. And as a result of that effort, I ultimately met Sam Stauffer and worked as a consultant in Washington. And finally, that led to my coming to Harvard University in the Department of Social Relations after I completed my degree at Princeton. But the war work that I did was partly done in New York with John Williams and Cecil Hastings and Jimmy Savage. We had a very small group called, we called it the Princeton Statistical Research Group Junior, because the main group was in Princeton. There was also a Columbia group in the same building. And indeed, my wife, Virginia, went to the Columbia group and served as a secretary for Alan Wallace, who was heading that group. They had an enormous collection of statisticians, including Churchill Eisenhart, Albert Bowker, Jimmy Savage, Wald, Wolfowitz, and so on. This was a very important move for me, partly because I got to work with Jimmy Savage and partly because I learned to work with problems, real problems, quickly. The problems came in and they always had a deadline on them, and I learned that the thing to do was to do what you could do and then write it up and have it ready, send it off, because it wasn't going to be of any value later. That was a marvelous experience for me. Until then, nothing I ever did was quite finished or quite good enough. After that, I learned to bundle it up and send it off.
Yeah. Now, what Fred didn't mention there, because it never struck him as much as it struck other people, is that just after that experience, if you heard somebody speaking in the next room at a party, you couldn't tell whether it was Jimmy Savage or Fred Mosteller, that they'd worked together so much that their accents and intonation and everything was really very close. He also didn't mention Milton Friedman, and that would be a mistake for me to leave that by, because I would say in the 10 years after that, if I were going to give a paper on statistics anywhere, the one person whose presence in the audience would make me most careful would have been Milton Friedman. Not anybody who claimed to be a statistician, but somebody who knew an awful lot of statistics and was very sharp to boot. There are good stories we shouldn't relate about just how much Milton had to do with moving on the affairs of SRGC. I think we didn't, in Princeton, we didn't have the same sort of short fuse experience, but we certainly had the real problems experience and the real data experience. And different kinds of experimental design than they teach you in the courses. We had, for example, eventually Eastman Kodak was building an experimental height finder, and when it was time for us to close down on that, I sat down and dictated 101 dictaphone cylinders. It was the draft report on the M1E9. So Fred got one thing which he needed, I must have got another which I needed.
Well, Milton gave both Jimmy Savage and me a very, very important lesson. Milton Friedman. He took a 100-page manuscript that we had labored over very, very carefully and wrote all over it on both sides. This was at a time when it was hard to get extra copies of anything because they just had to be made from scratch, and so we were very indignant that he would mess up a manuscript this bad. So we took his 1,000 corrections and explained to him the 22 that we thought were mistaken, and he then fought us into the ground. He wouldn't give a 1. Finally, at the end, he said of 2 of them, well, those may be matters of taste. But what was important was that when he got finished, he said, well, you fellas really have a lot of good things to say, and you ought to learn how to say them, and there's some ways to learn how to write. And here are a couple of books that'll do you a lot of good. Sent us off with these books, and Jimmy and I, for the next many, many months, worked very hard on this problem. It made a big difference, I think, to both of us, and it was the first time I think anyone ever took the editing of any writing that I had done or that Savage had done seriously enough to give us some motivation for learning how to improve our writing. It was a very important occasion.
Well, why don't you go on for a moment,
Well,
Fred?
I learned something else at this time, John, and that was that everything didn't have to be done by direct mathematics, that it was possible to do things by example, by approximation, and by simulation. I had done some simulation with Wilkes, with Olds, before I had left Carnegie Tech, but simulation seemed to be very often needed in the wartime problems that we had. And indeed, many of them probably couldn't be done even today by any mechanism other than simulation, though it was fairly slow. We didn't have a lot of heavy calculators available. One of the wartime problems that I had that was rather interesting was this: we had special bombs that could be aimed. They were called Azon or Razon, and there were heat homing bombs as well. These bombs could be aimed while they were in flight so that they would be likely to hit a road or even a point target. The trouble with them was that they seemed to have a very large standard deviation around their aiming point. And the question before the House was, how was it possible that bombs could be useful that had a larger aiming error than standard bombs? And so I was called to go to Washington to explain how that could be. And the answer was essentially this, that the radios in these little bombs would break in a substantial proportion of the bombs. And when they broke, they tended to lock their fins in extreme positions, with the result that the bombs would just sail off far, far from the aiming point. On the other hand, when the radio didn't break, then it was possible to aim them very carefully, and you could get a substantial proportion of hits on a rather narrow target, say 30, 40 feet wide, even though the standard error for the aiming would be of the order of 4,000 or 5,000 feet. So that I was required to go to Washington and explain to a very distinguished panel of people why this was. It was a first big experience I'd had with testifying about a statistical problem. John and I really didn't get to know each other until he came into statistics, but we did work together some in the war on a number of little problems, one of which had to do with the low moments of small samples. I had written a paper that gave the means and the variances of the order statistics in small samples, but they didn't give the covariances. When I showed it to Wilkes, he felt that if we didn't give the covariances, the paper wasn't satisfactory. It was very difficult to get the covariances. The problem, getting covariances for order statistics turned out to be a problem that defeated calculating machines for quite a few years, even after they became fairly good. So getting those covariances wasn't something that was going to come easily. Cecil Hastings, who worked for this Princeton group in New York with me, was very good at this kind of calculation, and so he worked hard on getting the covariances. Meanwhile, John Tukey and Charlie Windsor were with me one of those afternoons, perhaps a Sunday afternoon, I'm not quite sure, and I explained to them that it would be nice if we had features of these order statistics, not just for the normal distribution, but for some other distributions. And I had them, of course, for the uniform distribution, but there were other distributions it would be nice to have them for. And John and Charlie agreed to get the corresponding things for some other distributions. John, how did you do that?
Well, I think the question is, we went for a distribution where the chances of doing it were good.
Cheating.
No, not cheating. That's saying we don't have to go as far as simulation sometimes, that if you look for a case in which the representing function, the inverse of the cumulative, has a nice algebraic behavior, you can end up doing things of this sort in reasonably closed form. And so we did some of this, and so when the paper finally came out, it had some Gaussian information and some asymptotic Gaussian information and some information for the special distribution, which did a fair amount to illuminate how these things varied as you went to distributions that were longer-tailed. This was a distribution that was a little bit longer-tailed than the logistic. We weren't very brave in those days. Fred has said a couple of things that he got into as a result of wartime problems. Maybe I should mention a couple. I got into a robustness problem because when we were working on the B-29, we were supposed to be looking at the precision of machine gun fire from the aircraft. And well, everybody knew then, as everybody knows now, regrettably, that if you have things sampled from a Gaussian distribution, you should calculate the standard deviation in order to judge how broad it is. It turned out we weren't getting perfect Gaussian distributions. It turns out that if you add 0.1% of a Gaussian 3 times as spread out as the basic one, then already the mean deviation has passed the standard deviation as a way of measuring scale. And how you detect whether who's been by with a hypodermic needle and put 1 part in 1,000 of a slightly broader distribution in is a difficult point. The time you put in 10%, you can be pretty thoroughly ruined. And I think that this was essentially what got me started thinking about robustness, a topic to which I have come back more than once. Another thing that's just slightly post-war is that after I worked for fire control research through roughly the end of '44. Then that was sort of winding up. I ended up going to Bell Laboratories, and I worked there full-time for a while, and then September '45 things were turning down a little, so I came back to Princeton half-time and worked in Sam's project, not where I've been, where I saw more of Fred. But while I was at Murray Hill, we had an engineer named Buddenbaum who had been building a new, especially good tracking radar for tracking aerial targets. He wanted to go to California and give a paper, and he wanted a picture to show what his tracking areas were like. And so there was a question of calculating the spectrum, which was done by the best conventional methods. Dick Hamming looked at this and he said, well, if you only smooth it a quarter or half a quarter, it'll look much better. So the first thing we did was to smooth it a quarter or half a quarter and send Bud off with the picture. And the other thing was that Dick and I spent some months trying to understand why it was a good idea to smooth it a quarter or half a quarter. And that's where my spectrum analysis activities really got started.
I see. Well, when I came back from New York with Virginia, and she again worked for Merrill Flood in fire control research, I buckled down then at last to write my thesis. It hadn't been going too well when I left for New York, but when I came back, it was going fairly well. The only difficulty was I could rarely see Sam Wilkes for the reasons that John has explained earlier, and therefore John really became essentially the advisor on the thesis. And I went around to John from time to time and asked him for some suggestions, and he always did two things: took a pass at the problem I asked him about, and then he'd always suggest something else, something entirely different to work on. And I gradually got an important idea out of that experience, which was that it's important to get out of ruts and into some new activity that may turn out to be more beneficial than the rut you're already in and can't handle. So I owe John a great deal for that. The thesis got finished finally, and though the thesis was one that Wilkes had originally conceived, John certainly did a great deal of the final advising on the topic. At the end of that time, I was going to go to Harvard, but we were both invited to Lake Junaluska by Gertrude Cox for a conference following a program that they had given down there. And John offered to drive me there in his famous station wagon. And so we drove together.
Would you explain why the station wagon was famous?
Well, I
Point of elucidation.
suppose John ought to explain why it was so famous, but
It wasn't famous to me, so it has to be Fred.
it was the oldest living station wagon. I think was perhaps perhaps the most disreputable looking station wagon in Princeton. At any rate,
It was a 1937 wooden station wagon, and this was only 1946.
At any rate, it was a station wagon, and he was going to drive us to Junaluska in North Carolina for the meeting. And we hadn't been on the road a half an hour before he pointed out that he had organized a paper that we would write on the way to North Carolina and back. And so we did work away on it. He had an idea for developing something called binomial probability paper, which was very good for plotting up certain kinds of binomial information. And we wrote a paper, not really finished exactly on the trip, but we did a lot of work on it on the trip and shortly thereafter. Junaluska had a lot of A lot of exciting people. Wolfowitz was there, Fred Stefan, Phil Roulon, David Duncan. I think Charlie Windsor was there. Bill Cochran, R.A. Fisher, Gertrude Cox, of course, and many others that I probably can't remember. Fisher was in very good humor. The first day everyone was asked to say what he'd like to hear somebody talk about, and then after that list was put on the board, people were asked to volunteer to give talks on the topic. And the thing that interested me very much was that one of the topics requested was a write-up on Bayesianism, and R.A. Fisher volunteered to give the talk on Bayesianism, and indeed, I might say, it was one of the best talks I've ever heard him give in my life. He was always with us in the evening, drinking beer, especially with the younger people. He had a good time at that meeting, and we all had a good time too. I gave a talk about pooling data, which was a sort of a Bayesian talk. The idea is that you have means from two different sources, and the question is, can you estimate one of those means better by using information from both these sources instead of only one? And Fisher talked to me quite a bit about this idea. He never exactly told me he didn't like it. He didn't ever tell me he did like it. But he cross-questioned me very carefully for about 3/4 of an hour about it. And at the end, we parted. And as far as I could tell, we're still very good friends. Apparently, on some occasions at least, Fisher was very interested in Bayesianism and comfortable with it. Do you remember anything about
Well,
that?
I would suspect that was a question of you weren't trying to sell it as a matter of high principle, Fred. as a practical device, I think he could think about it. Well, there were various things. Fred has not mentioned the large organized game of hearts that took place up in the third floor dormitory.
Well designed.
As part of that meeting.
Well designed, too.
Yeah. But I think we ought to mention for the record the problems of keeping Fisher supplied with beer when this was a Methodist camp meeting that we were meeting at. We'll leave to your imaginations any questions about things, but Gertrude did it right, I think. Fisher treated me very gently. I gave a talk about analysis of covariance from a somewhat non-standard point of view. And I thought he was really quite gentle in pointing out to me how much of it really became the standard one if you just twisted it lightly. I might have expected to be much more roughly handled.
After we finished that paper, we got involved in some others, including one on a set of papers on industrial quality control, on quick and dirty methods. But I think the next big event probably was the work on the Kinsey report. Sam Wilkes was president of the American Statistical Association, and he was requested, I believe, by the National Research Council to appoint a committee to review the statistical methods of the Kinsey report. And he asked Cochran to chair a committee, and he asked John and me to join on that committee, which we did. It was a substantial effort, and we did actually produce a book, and from that book some articles were produced. I think John wrote some very original material on sample surveys in that book, and we got some very new thoughts about how social science and behavioral science were being carried out at that time. Mr. Kinsey was a self-made scientist and liked to do everything himself, And consequently, when he studied issues like variability, he did it essentially by simulation and was not really aware that there had been substantial statistical work done on variability. So that some of his work was criticized because he was not aware of these matters.
Yeah, Fred may or may not remember the time when the three of us were going to the train in Princeton to let Fred go back to Harvard and Wally go back to Johns Hopkins. And I think I can still quote Fred very accurately as saying, "They couldn't pay me to do this, they couldn't pay me to do this."
The visits to Bloomington, Indiana required a lot of work, and we had many, many long conferences there. I think we had to go to Philadelphia, to Baltimore, and work with Cochrane, and we had to read a great number of critiques of the book. We took each critique and cut it up into little pieces and tried to write a response to each of those critiques. That was a massive, really massive effort, but we did finally get it all done.
The implication is if you can do that, you can do anything.
I don't know. We later had an opportunity to work together on the National Halothane Study. The halothane is an anesthetic, and the question was whether halothane could be killing people from massive liver necrosis, because it had 4 halogens in its chemical composition, and halogens often did cause liver damage. We got to work in this enterprise with John Bunker, Lincoln Moses, Bill Brown, John Gilbert, Yvonne Bishop, Morven Gentleman, and a host of physicians. We met almost anywhere in the country, wherever John was. John, I think, was on sabbatical that year. At any rate, he was traveling a good deal, and the statistical team would just pick up and go and visit John wherever he was, Phoenix or New Orleans or wherever. And we attacked the halothane study with many different methods. 3 main methods, two being statistical, and one being a study of the actual tissues from deaths associated with anesthesia and surgery.
Yeah, I think there are still things for many statisticians to learn by see if they can find a copy of the report on the National Halothane Study and read the statistical aspects in it, because although if I don't say it, Fred undoubtedly will, about its having led to the Bishop Feinberg Holland book on contingency tables, not all the techniques that were piloted in there got taken to the book stage.
I should say that right now there's renewed interest in this area because Congress and also the executive branch of the government wants to compare hospitals in the quality of their care. And this means the problem of adjusting so as to have some fairness in the comparisons between hospitals that take severe cases and hospitals that take less severe cases. And it's not clear to me now how that should be done, even though I was very comfortable with what we did in the Halothane study. There seem to be more political questions involved in the new effort than there were in that Halothane study. Maybe I've become more sensitive, but I think not. I think that's a realistic part of the new
Well,
program.
maybe you were technically happier than I was. I wasn't unhappy in the sense that I knew anything better to do. But if you start rating severity of cases on a 5 or 7 point verbal scale, it's hard to believe that a verbally described severity in a hospital that only sees light cases is the same as that same verbally described severity in one that sees much worse ones. And it's very hard to understand how to make things so moribund will have the same interpretation. And without that you have some real problems. Certainly the adjustments that we went to were good things. I think we know enough now about making adjustments for broad categories that we might want to take those things somewhat further if we had all that effort to do again and all that data to work with. All that data being information on about 800,000 cases. That's a lot of data. But carrying on the expositional tradition, there is always the Green Book, and in that there is material on adjusting for broad categories. The thing that people forget is that you say, well, I'm going to cure the fact that there's this background variable. I'll dichotomize it, and then I'll look at the two halves of the dichotomy and sort of take what effect there is there and pool them together, forgetting that if the ratios are different, if you sort of slit a distribution across under a knife, the centers of gravity are not going to be in the same place when the distribution is over here and cut there as when it's over there and cut here. Being sure you make this correction accurately is not likely in a human affair, but you're a lot better off to make the correction than not. And this is one of the things that really did get into the Green Book, and I think it's right to direct people's attention to it, because it's a pretty widespread problem that people will feel, well, we'll at least take the people with low blood pressure and the people with not low blood pressure, and then not worry about the details anymore. We learned some of that from the Halothane study, because the data was all collected on the 800,000 cases before one began to look at it hard, and the ages had been coded in 10-year blocks, and it turned out that the risk of death from surgery about doubled every 10 years. So the distinction between 61 and 69 or 72 and 79 was a real important distinction, and if we'd only had better age data, we would have been able to squeeze things a little more, and if we knew more about broad categories, we could have done a little better. I don't think it would have affected the overall conclusions, but it would have been nice to come nearer to getting out of the data what was in there waiting for us.
Could I just ask, would you explain the phrase, the Green Book?
Fred, you explain the phrase.
Well, Gardner Lindsay had asked John and me to write a statistical paper for the second edition of the Handbook of Social Psychology. And John and I worked on that very, very hard, and we wrote much too much. And whereupon Lindsay took a share of it, and we were left then with a considerable extra bundle. So we decided to put the bundle together and create a book called Data Analysis Including Regression. And it does include some information about robust methods, as well as more classical kinds of things. and it especially has a substantial discussion of regression and the difficulties and hazards associated with multiple regression, and essentially says a lot about how little you can do with regression as well as how much. I think that's an important feature of the book.
Would you care to say something about, I think, what you call the Cambridge writing machine as a more recent work in collaboration?
Well, that's what I call it, and I'll talk about it a little and then let Fred talk about it. He wouldn't call it that. But there has to be some name for the Hoagland, Mosteller, and Tukey edited collaborative volumes, of which 2 are out and some more are in the mill. Somehow this has worked out very well. Fred and Dave have been very effective in persuading people around Cambridge, or who've been around Cambridge, and it's surprising how many of them were around Princeton before they were around Cambridge, to write chapters for these books. These are the things that are known in the trade as Eureka and edits at the moment: understanding robust and exploratory data analysis and exploring data tables, trends, and shapes. I'm not sure why this has been as good a solution as it has. The 3 editors have obviously been complementary and have beaten on very different things. The beating has been heavy enough so even though they're separately edited chapters, we've had compliments on coherence from reviewers, much to my surprise. Fred, what do you want to say about this in addition?
I think it's been helped enormously by some people behind the scenes, as well as by the collegiality of people who come and visit. First, the people behind the scenes. We've had 2 very helpful research assistants. One was Anita Perinack for part of this period, and the other for a much longer period was Mrs. Cleo Utes. And these people both have an important quality that this kind of work needs, and that is an eagle eye and an unwillingness to pass by something that they regard as possibly mistaken. And they just keep after it until finally they force the authors to get it right. I wouldn't say we don't have any errors in the books, that would be silly, but the number of errors is fewer by, I would think, about 2 orders of magnitude than they would be if it were not for the help of these people. And they also redo, we see all the examples and comb through the work. So that explains one of the positive features of the work. The other is that the number of people who are willing to participate in these enterprises is astonishing. I think they get some fun out of it, and then I think most of them take home when they leave Cambridge and go home to their own university. They usually have 1 or 2 more fixed to their bow, which they may use with other students later or in their own work. So it's been a very, very productive enterprise and profitable, I think, for all participants.
Right. Well, maybe we should turn to a closing topic. Are we about at that point? I think there's a few lessons that I would believe in very thoroughly. I think Fred would too. The first is that real problems deserve realistic attention, which implies it's better to have approximate solution to the right problem than to have an exact solution to the wrong one. This is not necessarily the attitude of the annals. Second, that one should intend to learn from real problems that they can be extremely suggestive over the long pull about both theory and techniques. Third, that the use of techniques is not confined to the instances that are covered by theory. If that was true, we'd be left with an awful thin set of techniques. If that were false, that you had to have theory to cover every application, very few techniques would ever get used. And I think the corollary to this, or the thing to which this is a corollary, is that statistics needs to be broad, not narrow. How about the rest of 5, Fred?
Do you care to add any comments on that kind of theme?
No, I think that pretty well covers it.
Well, then I think we are almost at the end of the time that is allotted for us, and I thank you, gentlemen, very much indeed for your marvelous series of thoughts and reminiscences, historical intuitions, insights, I should say. Thank you. Thank you.